Welcome to another teardown video. This time it's a vacuum tube voltmeter type RV33C. Wow, how old is this? I need to look it up. It's from Radiometer Copenhagen. Isn't that just fantastic? And the meter itself also is from Copenhagen. Fantastic. This is very, very heavy and very, very big. Oy, oy, oy. It's quite a lot of kilos. And I think the whole case is in one closed, sealed case. This was very normal for our radiometer products, and they were designed like this in a painted steel case. And here we see the mains input, a little bit weirdo connector, 50 and 60 cycles per second. Isn't that just fantastic? And when you need to open this or get inside, all you do is take out those 4 screws and then you lift out the entire thing. I think we should just try and power this up and see what happens. Banana input and some amplifier output stuff. Calibration. Where have we seen this before? This looks like a classic HP part from the same time period. So this, I think they didn't invent. Okay, power up time. Ready for the power on? Okay, first we see that nothing happens. Ooh, light. 32 watts, 30, 20, 19. Whoa, this is bright. Okay, so of course nothing is supposed to happen. Oi. Why are you doing like that? It is going absolutely bonkers. Oi, oi, oi. This can't be good. It is about to break the needle here. It's just... oh. This can't be good. 30 watts and it's just measuring all sorts of rays from space. Or is it my cell phone? Let's try and go a little bit further away. No. It's just oscillating and going... Oi! What happened? So that means this is... Oi! Look at that! Quiet. Ooh. Okay, we need to fix this. The switch is definitely what is causing this to be. Ooh, okay. So, let's take a break and I fix a little bit. I actually got something working. I connected a generator, 1 kilohertz, 1 volt RMS. And we get this reading. So this is 1 volt input. This is 2, 3, 4. Okay, let's go back. Now we got 2. 1 again. Okay. So this is 1 volt. I think it's definitely something with this switch. Because, see? Just before I was able to put this in a position where it actually worked. Oh, okay, good. Now it's happy. Okay, so this is 1, 2 volts, 3 volts, 4 volts, 5 volts. See? So it is possible. Okay, that's 4. It's 5, 4, 3, 2, 1. And so it's clearly this switch that is really, really bad. So, it's time for teardown. Yes, I was right. All you needed to do was to unscrew the 4 corner screws and lift up the entire unit. So let's have a look here. Mains input, voltage selector. Don't you just find this a really, really cool way to do it? You loosen some screws and then move it. So to remember what you have done here on the internal, look what you do here. You unscrew this, and then you can tell on the outside what you have done. So this is just an indication. This is not doing anything but that. Isn't that just cool? Alright, so that was the mains input, and then the blue wires to the on-off switch. And then this is a Danish brand, Jensen. Very, very known in the good old days. Rectifier tube. And then the rectified high voltage comes to the first capacitor in this red wire. And those are double capacitors. Very, very normal in the good old days. Bleeder. No, those are not bleeder resistors. Those are, of course, series resistors or filter resistors to the next and to the next and to the next. And this is again very normal to use a lower and more filtered voltage. The closer you get to the input, the more critical your DC supply is. And also what you see down here is, I'll find something to point with. The filament voltage goes to a voltmeter with the center point to the star ground, and then you can trim this for hum balance of your filaments. So that is also very nice and normal. The powerful bulb in the front of the meter is here, also connected to the filament voltages, series resistor to that. So now we got all the nice voltages, and then this is the, let's turn it all the way upside down. This is the input range or attenuator. Quite simple made. Look at how they shielded or closed the metal around that opening. Quite amazing. And again, the input here is the ground lift, and then the black wire goes to, this is their signal star point for the amplifiers and stuff. This capacitor is really cool. So it's connected from the first tube back here, and this is the gain from the first tube is just a cathode follower, and then the output from that one goes through this, and then via all those different resistors and stuff, and back to the next tube. So that's all the filaments and the brown wires. Yeah, really, really classic build from the good old 50s. So this design is from 1950. How about that, huh? So this is really, really old. And the 4 tubes. And look at this. Let me try and... Yes! This is not so normal in the later designs. Normally when I pull stuff apart, they're not using this type of socket, and they're not using this type of glass. But I really like this because you can't put in this tube the wrong way, you always know how to put it in. And look at those pins, they're really black and dirty. So I think I'll try and clean up all the pins and the voltage range switch, and then I'll try and boot this up again and see if it is any better. Now I cleaned this up a little bit and it seems to be a little bit better. I'm trying to see if there's any capacitors defect. Maybe I will have to scope this a little bit, but it's 320 volts. What if we go to AC? 1.7 volts. What if we take this and measure on the next set? Ooh. Almost no AC. We've got a lot of DC. So that proves this system actually works. See? Got a lot of DC, but the AC is so low, this meter can't even pick it up. Oh, it is sometimes picking it up. So that's 150 volts. So that's pretty good. But why isn't it working any better? So this switch is just absolutely rubbish. Yeah, that is definitely the problem, is this switch. Other than that, the instrument seems to be working and in good order. So, but I can't do a lot without spending a lot of time fixing this switch, and that is not going to happen. But this instrument can be saved. Just clean and fix and maybe change some parts in the switch, because look at that. Ooh, this is clearly alive. And once again, let's look a little bit in the schematics and in the documentation. Thanks again to peel.dk for providing Radiometer schematics and manuals and everything. And here is how it's looking. 20 cycles to 3 megacycles. Don't you just love it when it was like that? This manual is really good. It's detailed about the frequencies and the performance and all this. I really like it. You can see that it was done by hand. Oh, here it is, 5.7 kilos. And the power consumption, yeah, that is even right. And here we go. A classic typewriter. I didn't see any typos so far. Let's go down to the schematic. Is in the, here it is, the schematic. So here is the input AC that goes through the first, either the direct way or via a 2 mega ohm resistor. And then this input goes to a cathode follower, and then the output from that one goes to the next section of the attenuator. And then this signal here goes to the next tube for further amplification, and then to the meter and the 2 diodes. And here is the rectifier diode, or the rectifier tube, and like I said, the dual capacitors with all the series resistors. This is a super classic way to make tube products or tubes designs. They were all done like this. And this is actually a forgotten design. So nobody does this anymore with transistor designs, but I really think we should do this today to filter our supplies like this. The further we go to the more and more sensitive parts of our circuits, it's always good to have series resistors in series with our capacitors, and this way we can get better and better quality of our supplies. But of course, analog circuits, they're not going to perform without good clean supply. So that is all this product contains. That was the voltage input selector. And look at this. Everything is handwritten. It looks like they had some copy-paste tube symbols.